Hey gang, Professor RZFeeser here. I teach a lot of classes on cloud, Kubernetes, containerization, network function virtualization, just running apps on servers like, SIP applications for telecom. And inevitably students ask a question, which is, how do we trace on this stuff? Network traces. How do we see the packets going in and out of these applications, of these devices, of these network interfaces? The standard is TCPdump. TCPdump is a utility that is found on most Linux distributions, and it lets you create files called PCAPs. Now, you may have worked with a utility called Wireshark. It does let you create and view PCAPs. Primarily, the draw of Wireshark, though, is a human and a GUI. If we're trying to analyze a remote system, we can't assume that remote system's going to have a GUI. In fact, it's more than likely that it won't. So what we want to do is SSH to a remote place. We want to turn on this tool called TCPdump. We want to save the output, but not locally. We want to send it back across the SSH tunnel, where we want it saved on the jump box where we started from. We want to do that all in one whack. We want to be able to run that command. And when we run that command, it produces the PCAP on the local machine. Now I have something special here for us as well. The machine we're going to target is a SIP server, specifically an asterisk server. And what I have set up is a SIP trunk on that machine. So we're going to SSH into the remote terminal. I'm then going to call it, right? We're going to make a phone call, go into the box that we're SSH'd into, that we're running this trace tool on. Why are we doing that? Because that will be very distinguishable traffic. There'll be a phone call coming in the middle of the trace, which again isn't going to be saved on the local machine. It's going to be piped back to the jump box, the analyst terminal. So believe it or not, everything I have up on the screen is all you need. SSH, that creates our connection to the remote system. Student at, that's the username you're going to use, at the host you're going to. So bchd.that long, that could be an IP address, a host name, whatever. It gets you to where you're going to. What's in quotes you might need to tweak a little bit. Sudo tcpdump turns on the tracing tool. -I is the interface. ENS3 is an interface that exists on this remote system. I don't believe you even need that command. If you're going, well, I don't know what interfaces would be there. You could SSH in and do an IP space A and you would see them. But you could also just delete -I space ENS3. Delete that flag and delete the ENS3. TCPdump should just run on all interfaces then. The -W space hyphen, -W space dash is important. That's right out. And normally we'd have a file name, but we don't. We have redirection into tilde static output.pcap. And that file location, everything after that redirection, the tilde static output pcap, is not going to be interpreted as a location on the remote system we SSH into. It's going to be understood to be here on our jump box analyst terminal. So what I'm going to do is hit enter. The command's going to begin running a trace on the remote system, but saved here on my box. I'm going to call the phone number for this remote system. That should make a SIP phone call go into the trace. I'll hang up. We'll stop the trace, we'll open it, and we should see that SIP call in there as proof that this actually worked. All right, here we go. Okay, gang, let's go ahead and hit enter. And that should begin our trace. It says it's running. Remember, this is actually running on the remote system. It's just pulling the results back to this jump box. I'm going to click over actually to this remote system. Here I am on this thing called an asterisk server. This is where the SIP traffic terminates to. Specifically, what's down at the bottom? That's the visual log. That's the standard out log you're seeing. We should see some evidence here as I dial the phone number, the DID that points to this machine. Should be ringing here in just a moment. All right, it's picked up. And the evidence we actually, there you go. It's talking about a sampling rate. It's saying it lost a frame here or there. It's RTP. It's losing some data here or there, but that's okay. We can hit end on there. Believe it or not, we're done. I can Control-C and stop our trace. As far as where did we save it? We saved it into static. There is output.pcap. Gang, what we're looking at here is a file server that's set up to read the contents of that static folder, which is why you see output.pcap. If I click on it and download it, I can open output.pcap in Wireshark. Wireshark is for viewing, primarily for viewing. You can make captures with it, but like I said, it's GUI based, so we pretty much think of it as viewing captures that we create, usually with other tools like TCPdump. We said one way to validate this was the actual trace is there should be a single call in here. If I search on SIP, which is how phone calls are made, we should see an invite. We see an invite, we should see a buy. Excellent. That's pretty good assurances that we did indeed SSH to a remote system, make a trace, but save that trace back to the jump box where we started from. Wow, gang, what we just studied was truly awesome because the applications are endless. Don't get bogged down that this has something to do with SIP. The command we just learned, which is on the screen right now, can be tweaked to fit lots of situations. Anytime you need to go into Linux infrastructure and make a capture, this technique should work for you. Gang, I teach a lot of classes on everything we just studied. Additionally, there's some really cool things going on here. Asterisk, for example, SIP, Wireshark. I'm going to have lots of videos coming out that explore this lab setup I have here in a little more detail. So, you don't want to miss that. Hit like, hit subscribe. I'll see you in the next episode of Code with Feeser.